Okay. Hi, everybody. Today I am recording this lecture. I will cover week 7 topic, which is control charts for variables. I'm going over control charts for X bar and R. Okay. So this is the class website. Here's the chapter 6, part 1. You'll find the PowerPoint here, chapter 6, part 1 PDF. And also you will find Excel sheet for problem 3, page 92, which is the same problem I'm going over right now. So you will have this question on your textbook. So we have control charts for variables, which is we use to control a process to see if the process is in control. I assume that you read the material, what's variation, what type of control charts, what's the meaning of variables, because later we will cover control charts for attributes. So after reading the examples from the book, I recommend that you watch this video and learn how to calculate the control limits, central lines for control charts for X bar and R, and how to create these charts using Excel. Okay, so the following table gives the average and range in kilograms for tensile tests on an improved plastic cord. The subgroup size is 4. That's very important to know the subgroup size, because later when we calculate the control limits, we need some factors, and these factors can be found from table B from the textbook. Okay, based on the sample size, determine what we call the trial central lines and control limits. If any point R or point R out of control, assume a single cause and calculate the revised central line. So this is the data. You know, we are not given the raw data, which we are given the X bar for each subgroup. So we have subgroups, and the original data was like this. This is, for example, 1, 2, 3, 4. So our sample size is 4. So we have data here. So they found the average for each subgroup, and it's given here. So this is the average for the first subgroup, the second subgroup, and this is the range. So we are given the averages and ranges for each subgroup. Okay, that's what we are given. Sometimes we would be given the raw data. I think like the example, let me see if we have another example with raw data. Oh yeah, like this one. So for example, you can see here, we have subgroup 1 to 25. So this is subgroup 1. Okay, so the average for X bar 1, you add this up and you divide by 4, which is X1 to X4 divided by 4. So this will give you X bar 1. So in our example here, which is the problem, we are given this information. Okay. Go back to the example. Here. Okay. So now we need to calculate the control lines, the central lines, and the control limits for X bar and R charts. Okay. So now what I need to do first, I need to write down the equations for the upper and lower control limits for X bar and R and the central line. So upper control limit X bar, lower control limit X bar, upper control limit R, lower control limit R. So these are the trial lines. So you have in the book and the PowerPoint trial line revised. So we will first find the trial and plot the charts, and then we revise it after finding the standard deviation and plot it again. So what's the formula for this? It's in the book. So the upper control limit is equal to what we call X double bar plus A2 R. The lower control limit X double bar minus A2 R. The upper control limit for R, it's equal to D4 R. Okay. The lower control limit for R is D3 R. Okay. You can find these equations here or in your textbook. Let me show you where these equations are. Yeah. See, these are the equations, the trial control limits. So X double bar, we need to find the average of averages. So we are given the average for each subgroup. We need to find the average for these. And A2 and multiplied by R bar. Okay, let me copy this. These for the revised, okay? We still work on the trial ones. I will put this here. Okay, so now let's start with X double bar. X double bar is equal to the sum of X bar divided by N. What's the sum of X bar? We said we already are given the X bar. So we have from 1 to 25. So we have 25 subgroups. This is X bar. I need to add these up. Okay. And divide the total by 25. How much? If I add these up, I will use Excel because it's faster for me. But for you, you need to add them up. So if you add them up, you will have 12063. So now 12063 divided by 25. So this will give us the X bar, X double bar. Okay. So now I have this piece of information, and then I need A2. A2, it is based on the sample size from table B. So I need to go to table B. Where's table B? It's in your textbook in the appendix B, based on the sample size. What's the sample size? It's given. It should be given. So it's 4. So I need A2 4. This is A2, 0.729. I put here A2 is equal 0.729. Okay, so now I have A2 R bar. R bar is equal to the sum of R divided by 25 because I have 25 samples. Go add these R bars up, R's, and divide them by the total. Here's the R. So I have the sum equal to the sum of the R's. 626, okay? 626 divided by 25. How much? This 26 divided by 25 is equal to 25. So here I have 25. So forth. Now I can calculate this piece and this piece because I have x double bar is equal to x double bar 482, right? 482.5. Okay, 482, that's what I should say, 482.5 is equal to 2.5 plus 7. We said 29.729 times R bar, which is 25. Go for lower control limit X bar is equal to this value, 82.5 minus 729 times 25. Okay. Now for R, of course, the central line here is X double bar. This is the central line for X bar, X chart. Okay. We said we have upper control limit R is equal to D4 times R bar. Lower control limit R is equal to D3 R bar. Of course, D4 from the table, again, I go to the same table. Where is that table? Oh, here. Okay. I need D4. So you look at the table based on a sample size of 4. Where's D4? Here's D4. Here's D30. 2.574. 2.574. Based on a sample size. Oh, here. No, it's here. Let me draw a line. The 2.5 is for sample size 3. Okay, this is my D4. This is D3. Okay, and later I need small D2. I need small D2, which is here. Later I will need the calculate sigma. Okay, now I plug in the numbers that I have. I already have D2 as 2. D4 as 2.282 times the 25.04, and this is D30 times R bar, so this is 0. Now I have the control limits and central lines. So anytime I ask you on the test, on the quiz, to calculate the control limits and central lines, you need to do this process first. You need to write all equations, okay, to find X double bar, R double bar, and writing the equations for each one. Find the factors, which are 2, 4, 3, and later we will need more factors to revise the chart. Okay, then after that, use the information to calculate the upper control limits, lower control limits, central lines. Okay. So I did that. I calculated the upper control limits for X bar and for R. Yeah, the central lines, the central line for X bar chart is XD bar. The central line for R chart is R bar. Okay. Now I did all the calculations. I understand what does that mean. So if we want to draw this by hand, we already have the XD bar, X double bar. We have the upper control limit, X bar, and we have the lower control limit, X bar, and we draw the X bars, which are the averages for each subgroup, and then we can see if anything is out of control. And we discuss that. We say, oh, okay, subgroup 5 is out of control. That means the process is not in control. So something wrong with this subgroup 5. We go back to subgroup 5 and find, oh, what's wrong with this? Is it the machine? Is it the operator? Is it the raw material? So this is how we control our process. And then we decide, after we decide what's wrong, where this error came from, we revise it, set up the machine again or whatever, and then we plot the chart again. And this is also the R chart. You can have something. Okay. Now you go to Excel and build these charts in Excel. So as I said, first, what's wrong? What we are given here, we are given the subgroups, right? 25 subgroups. We are given X bar, given this column, and we are given this. You know, let me say something here. Sometimes, I will go over this later. Okay, let's continue the Excel. So XD bar, I already calculated XD bar, right? I did that in Excel and by hand. So I just type XD bar, it's a number here. It's a line, okay? R bar, also the average of this line, okay? And I do the same what I did by hand in Excel. So I here upper control limit is equal to X double bar, which is 482, plus N2, I have A2, which is 0.729, times R bar, which is I already have R bar here. Okay, I do the same thing for each. I put this just to know which one is out of control. Okay, and then I plot these in Excel. So this is the X bar chart. Okay. If I want to plot these, let me start with XD bar. I just insert scatter plot, okay, and then I change this to be a line. Okay, it is necessary to have title charts, subtitle charts, axis titles. So this is the main title chart. It's X bar chart. Okay, it's not XD bar. X. You know how to do that. Okay. I add axis titles. Now I need to add the other charts, which is this one, the upper control limit. I leave this, I need the y-axis here. Okay. Add the lower control limit, X bar. So now I have the central lines. Now I need to add one more. Which is the X bar itself, to see if anything is in control or no. I just add X bar here. Okay. Now I fix this. I say all of them. Oh, I need to fix the central line also. Central line. Where's the central line? It's gone. We did not draw the central line. We need to draw the central line. Okay, let me draw the central line. Yeah, I don't have central line. X D bar. Okay. Now I can fix it. Okay. Then if you fix it, you will get a chart like this one. Okay. With all the titles. Now I can tell that I have this is out of control, right? I don't know. Yeah, this point is out of control. I think this one also. Okay. So the point that is out of the control limits. Okay. Do the same thing for our chart. Okay, so I have here this is the X bar, this is 464, okay? 464. So I have the control limits. The upper control limit is 482. Any point from here above this is out of control. So I have this one is 506 and this one is 506. Okay. The lower control limit is 464.2. So this is less and this is less. So I have 4 points out of control. And also nothing out of control for the R chart. Okay, so now my process is out of control. I need to revise this process. Assume assignable causes for the errors and calculate the revised control limits. How do we calculate the revised control limits? Okay, this is how we calculate the revised control limits. Put the equations here. So now X bar double bar naught or X bar naught, which is the new X D bar, the new X D bar plus A sigma naught. So I need A and sigma naught. Okay, let's see. So after you first, you need X double bar new equal to, or what we said before, we have 12063 was the total, right? Here. I remove these values, minus 464, okay? Minus the out of control X bars, 464 minus 506. I have 506 minus 506 again, the second one, minus 463, right? Now, the new average, I used to have 25 minus 1, minus 1, minus 1, minus, which is minus 4. Okay, now my new average, I calculated, maybe it's 482. Okay, so this is the new XD bar. That's what I need. I need A from the table based on a sample size of 4. Let's go to the table. Okay, sample size of 4 here. For A, it's 1.5. So I have A. Oh, where's the here? So now I have X double bar new. I have this 1.5. I need sigma. Again, our sigma naught. Sigma naught, when we are dealing with X bar and R chart, is equal to R bar new divided by, as I said, D2. So now, look, do this. I have to remove these 4, okay? Let me go to the revised. So, which are number 12, number 15, number 19, number 23. I already removed number 12, you see. Number 15 I removed. Okay, number 19 I removed, and number 23. So I have now, this is my new XD bar, this one, and this is my new R bar. Okay. So now my new I bar is 25.42. So now sigma naught is equal to the new R bar 25.42. Let me check. Yeah. Divided by D2. How much? We said D2, it's from the table. We said it is 2.059. Then this is will be sigma naught, which is 12.1. Since I have sigma naught, I can calculate the revised control limits, and I have sigma naught. I multiply it by D2 from the table, D1 from the table. I get the control limits and central lines for the revised R chart. Then I do the same thing. I put all the new stuff. You see here, I have sigma naught, I have A, I have all the information, and plot the process. And now my process is in control, you see. Nothing is out of control. Again, when you calculate the sigma naught, remove the out of control points from both charts, from R and from X, and calculate the new range, and based on the new range, R bar, based on the new R bar, find sigma naught, okay? And then plug in the sigma naught in the equations and plot these new charts, okay? Here in this example, a sample of n equal to 6 items each are taken from process irregular tables. The quality characteristics as measured. X bar and R values are calculated. This here, I think we are missing X bar. Okay. Are calculated as follows. So here we are given the sum of X bars and the sum of R's. We need to find in this question, we just need to calculate the X bar and R charts, central lines, and control limits. As we said, the first, I put all the equations. Upper control limit X bar is equal to X double bar plus A2 R bar, lower control limit X bar, X double bar minus A2 R bar. Upper control limit R is equal to D4. Okay. Lower control limit R is D3. Okay, this is the first step. See, I put all the equations. Then I find X double bar. X double bar, it's given here. We know the sample size. And here, look at this equation here. What we are given from here, we are given X, the sum of X bar is equal to 2000 from 1 to 50. So we have 50 subgroups, okay? So X double bar is equal to 2000 divided by 50, it's 40. Okay, R bar is equal to 200 divided by 4. Now, I have X double bar, and then I go to the table and find A2 based on the sample size of 6. So N equal to 6 from the appendix. So I find that A2 is 0.4. So this is the upper control limit. This is the lower, and this is the upper control limit for R. This is the lower. And then something that we will cover later. If I want to find the process capability, it is 6 sigma naught. First find the process capability, which is here. CP is equal to upper specification limit minus lower specification limit divided by 6 sigma naught. So the upper specification limit and lower specification limits are given here because in the process it says if the specification limit is 41 plus minus 5. So the upper is 41 plus 5. The lower is 49 minus 5. Okay, so 46 minus 36, 6 times sigma naught. Sigma naught is the same. We calculate sigma naught based on R bar divided by D2. D2 from the table, 6 times sigma naught, 6 times R bar over D2. So CP is 1.05 based on the information that you have. If it is below 1.26 or 1.30, so the process is not capable. Okay, we'll cover this capability studies later, but I have it here, so I have to explain it. Okay. Go ahead and read the material and the examples and try to do the homework. And if you have any questions, please contact me. Thank you.